Hello, and welcome everyone, thanks for coming. The slightly flippant title of my talk is Better MIDI by Friday, and that alludes to the fact that I want to talk about some of the many things that are happening in the MIDI Manufacturers Association, but the ones specifically, the ones specifically that are imminent. So it's not actually by Friday, but we hope that they're ratified soon and they become part of a spec. Is there something we can do about that sound? Okay, do you want me to keep talking?
Well, let's get it in Mark's
Okay. Technology. Okay, well it probably is on. Can everybody hear me anyway? Oh good. Right, let's be handheld. So there are two things I want to talk about specifically. The first is MIDI capability inquiry, or if you're American, inquiry. And the next generation protocol, which I will say very little about because, well, it'll become clear why I'm not going to say much about it. So 3 quick disclaimers. If I'm speaking on behalf of the MIDI Manufacturers Association, it saves me saying these things now so I don't have to say them with every slide. The first thing is time. I have 25 minutes, I think, to explain the things that I need to explain, and that's only really time for an overview, and it's a time to inform a little and enthuse a little, but it's not a how-to, and it's not a tech demonstration, it's simply an introduction to what's around the corner. The second caveat is I have a front row full of people who know much more about this subject than I do. While I led the effort for MPE and I chaired that working group, I'm much more of a passenger in the capability inquiry working group and in the next generation MIDI working group. So as well as being able to answer questions, I'll probably also try and question answers. And I may not be the authority in the room, and I fully acknowledge that. So please feel free to interrupt and throw things. The third thing is fake news. When there is consensus-led development of any specification and you have a lot of commercial vested interests attempting to cooperate, things can change quickly, people can get more involved, and suddenly things that you thought might have been unassailable become quite problematic for a few users, and things end up changing in specification committees. So everything you read now is an intention right now, but stuff might change, so don't treat it as infallible. Okay, so now I've said those 3 things at the beginning of my talk, I don't have to say them on every slide. MIDI capability inquiry, what it is, why we need it, what it does, not necessarily what it is. So if you go back to the late 1980s when MIDI was MIDI was conceived in the early 80s, but over the next few years it kind of popularized and settled down a bit, and the use cases became entrenched. So this is a traditional use case of MIDI and the kind of thing it does very well. You have an Atari ST there because they handled MIDI natively, which gave them an effective monopoly in recording studios for about 20 years. And a Super Jupiter, so a mid to late 80s example of a synthesizer module. And what MIDI is very good at is this monologue, and that's how it exists at the moment. So you have the Atari ST telling the synthesizer, there's a tick to synchronize its sequencers and arpeggiators and various note rate parameters. There's note events, so you can play C# 3 velocity 100 and you can release it at the end. Control messages, pitch messages, all very well defined. Everything knows how to process them, and it's very good at that kind of one-way conversation. The other thing that MIDI has been quite good at from the start is manufacturer-specific dialogues. So you can say the computer can say in Roland language, send me preset 1, all the data you have, and the device will respond in a manufacturer-specific language, starting F041, which is this is a Roland packet, and ending F7, end of packet, and everything in the middle is manufacturer-specific. So it can be documented as much as a manufacturer wants it to be, and you can transmit data and receive data that way, but everything that you do is germane to a manufacturer and a specific product. So you can have dialogues in MIDI, but they're not really part of the open specification. So if you think about the first 2 decades of MIDI and how it was used and why it was conceived, physical interfaces were quite an expensive thing. So a computer has 1 MIDI in and 1 MIDI out, and that's the way it talks to everything. There is 1 port and several channels, and all of those channels are used to communicate with different instruments or with different patches on the same instrument. So your MIDI studio is 1 cable made long. Equipment shares the same port through MIDI through, so MIDI through was the 3rd socket on MIDI devices, and all that does is echo what's coming in the MIDI import outwards again, so you can daisy chain things together off the same MIDI line. And MIDI is a lingua franca, so there's manual communication at both ends. You'll set up your patch before you play it, you'll make sure that the synthesizers are set according to what pitch bend you expect, and and the volumes are set nominally, and everything gets configured at the computer end manually and configured at the synth end manually. And from that setup, you then start playing out MIDI and recording what comes back. And that was the way that a MIDI studio would have worked for quite a long time, probably up to the early 21st century. That's why MIDI was originally conceived. You've also got this other layer of stuff which is kind of semi-open. So there's a universal system exclusive message. You don't have to read all this. It's just there to demonstrate the fact that it does exist, called device inquiry. That is a hello, what are you message. And many devices do follow this specification. You can speak to something at the other end of a cable not knowing what it is, and it'll reply back giving you its manufacturer and device numbers. This is sort of useful, especially in the days of Windows XP when every class-compliant MIDI device you plugged in was called USB audio device, and you didn't know if you were talking to the piece of equipment that you wanted to talk to. This was great for disambiguating that kind of thing. So there are great advantages to this part of the MIDI protocol. The first thing is that we can confirm that we're capable of dialogue, and we're not speaking down a DIN cable. We're speaking through 2 DIN cables or a USB cable, and we can actually get a response from the device we're talking to. We can chat to our friends. So if we recognize the manufacturer ID and the device ID that's coming back, then we can start having a conversation. We can be a patch librarian or some kind of firmware upgrader or some sort of sequencer downloading samples or patches or other things. So we can have that dialogue. Device inquiry is not universally supported. There are some things that will just sulk and not send a response. There are some MIDI devices that are so basic they don't even handle system exclusive messages. I wrote one once. In the days when 8-bit processors were around and you had very little RAM to handle MIDI packets and you had very little ROM to write your firmware in, it was actually fairly standard for system exclusive messages just to be ignored. And that's still the case for a few devices even today. And everything we haven't explicitly coded into our software, everything we don't have a lookup for in our manufacturer and device IDs is still a mystery to us. So there's no way of building on top of the open MIDI specification something that's more general without going to the Manufacturers Association and writing a new recommended practice. So there we are. And then there was this thing called General MIDI, which came out around 1991 as an attempt to make the specification a bit more generalized if you're a transmitter. Actually a lot more specific if you're a receiving device. So it's either general or specific MIDI, depending on which hardware you make. But that was when channel 10 became the percussion channel, and that was when the drum map was worked out. So the bass drum is on C and the hi-hat is on A flat and B flat for some reason. And when various patches and presets were put in the standard places. So piano is the first preset you have, and then the very curious telephone ring and dog bark patches were put in at the end somewhere. All of that was part of General MIDI, and while General MIDI is a more elaborated specification, there are quite a few synthesizers now that just support that automatically. You turn it on and it's in General MIDI mode. So that was an attempt to standardize some deeper things. So latter day MIDI, we have this wonderful situation where we can communicate from a computer to a device, and if we recognize the device, then we can have a manufacturer-specific conversation with it. This is a general MIDI. This is a genuine MIDI stream, and I can't remember what it means. I think it's just a status stump, so you can get the initial settings of a C-board rise. But that's the kind of thing that happens. Unfortunately, if you're trying to write a generalized piece of software, then you plug in some other device. Welcome back to 1983. We know how to talk to you in that language that we invented originally, but it's quite hard to build a richer experience. So this is what we're trying to improve. I've got a mini Nova there, by the way. I was told that it might be pejorative to use another piece of manufacturer's equipment, so I picked one that I designed many years ago. So yeah, I'm guilty of that. It's a very nice product. So these days we have this kind of explosion of devices that do one thing well. We've moved beyond general MIDI, so it's the attack of the drawbar organs, for example. And it would be nice if you had the software and hardware drawbar organs that emulate B3s and other drawbar things. It would be nice if you could say, well, I've had this piece of equipment for 15 years, I wonder what it sounds like if I load up the latest wacky software plugin that's a B3 emulation, and if it sounds any better. And you can kind of do that, but there's no way of setting up that new software plugin exactly as you had your old one, unless all the manufacturers have colluded, and there's no way necessarily of having the drawbar changes mapped to the same control parameters. So when things change, MIDI has to change very slowly, because the general MIDI spec is huge. There's billions of dollars of R&D already vested in it, and these things necessarily change at a geological pace. And so we have things like drawbar organs. We have new emergent devices such as expressive controllers. So eigenharp, hack and continuum, Blinstrument, Seaboard, all things that allow per note expression in a much richer way than was originally envisaged by MIDI's creators. And we also have things like grid controllers where, okay, there may be some variations on a theme. Blocks is rather different from an Ovation Launchpad or a Monome, and the lights might do different things, but in the end you have an 8 by something pad, and to be able to use some kind of lingua franca to communicate with some other manufacturer's pad is great for the manufacturer and it's great for the community. So there are things that MIDI could do better, and this is where capability inquiry comes in. So there are 3 things that we're setting out to standardize in some way. The first thing is protocol negotiation, which is a future-proofing. The second thing is profile configuration. I hope I'm getting the verbs right, so that we can have these general devices that don't necessarily have everything that general MIDI requires them to have, but nevertheless can talk in a kind of class-compliant way with other MIDI devices. And we have property exchange. I'm going to use exchange, where the control messages and mappings and patch names and so on can again be exchanged in a standard way. So we'll start with protocol negotiation. I got the verb right. Brownie points. All devices still speak MIDI 1.0, the specification that we all know and love today. If both devices support another protocol, and then they can say that they both support it, then they can agree between them to switch. And one device will be dominant and the other device will be submissive, and there's a kind of arbitration process whereby one is allowed to switch the other. And the test message between them once the protocol switch has happened ensures that everything's gone all right. And if it hasn't gone all right, then it can fall back to MIDI 1.0 again, so customers don't get aggrieved if something doesn't quite work as advertised. The thing that isn't part of this, that I've had to change from my original slide presentation, but is still worth mentioning, is that with USB MIDI, you have a theoretical very fast data transfer rate, and nevertheless, computers still restrict you to the DIN rate of 31.25 kilobits per second, which is exceptionally slow by modern standards. The reason for that is that if you try sending fast stuff to a device such as a MIDI DIN interface that converts you to the old format, and its buffer gets full, it can possibly crash because it's not been tested when the buffer gets full, or it can start dropping packets and behave suboptimally. And so it's much safer for the driver writers at Microsoft to say, right, we're throttling everything that says it's a MIDI device, just in case this happens, because we don't want support calls and we don't want negative publicity. So there is this speed limit on even USB MIDI. It would be great if we can lift that, because things like the Seaboard, where you send very fast rates of data out of it as a matter of course, suffer, and you have to affect the temporal resolution of the data you're sending in order not to fall foul of this limit. So that's something that we're going to be doing in future, but probably part of the USB MIDI specification and not a layer on top of that. Next thing is that manufacturer-specific protocols are supported. So a third party can come along and write a new protocol, and they can attach their own manufacturer ID to it, and anybody can use it. It doesn't have to be that manufacturer. So the protocols can have manufacturers as well as the system-exclusive messages. And it means that there can be an explosion of ideas in the marketplace if that's what we want. Next thing is profile configuration. This is the most exciting part, I think. Profiles specify, it's the second most exciting part, I'm building up to it. Profiles specify how a receiver responds to certain MIDI messages. So the drawbar organ is an example of that. The profile will be followed by the hardware or the software you are making that makes the sound and receives the messages. And it's not something, they're not properties of the transmitter. Receiving devices have profiles, transmitters don't. They might support them. This is an early draft, so the shouty caps there is, if anybody's watching this on the video and is making a drawbar organ, they don't just copy this MIDI implementation chart. This is an early piece of draft work, and it's being used by a couple of manufacturers at the moment to try and get the profiles tested as a proof of concept. But as you can see, drawbar organs being very much based on a Hammond prototype, there are perhaps 8 to 10 sliders, there's a percussion control, vibrato, rotary speaker simulation. Every drawbar organ simulator in the world, as far as I can make out, will support all of these, and having a profile will give them a standard controller map, and it can be a controller map that interferes with other different profiles that might be doing other things. I can turn the shouty caps off, but I think I finished talking about this, so I can move on to the next slide. Profile configuration. What are we talking about? Yes, a device can support many profiles, and the profiles can be channel-wide. They can be independently turned off, and they can either be device-wide, so a whole device can switch to a profile, or they can be in one MIDI channel only. So it's a little bit like taking general MIDI and splitting it up into a much more explicit way of doing things. So specific devices can implement part of the general MIDI specification or part of a new MIDI specification, support control mappings on certain channels, and have have program change numbers in certain places, and you can make very specific devices that still talk in a standard way to other kinds of devices in that class. They can be turned on or off. So it's kind of, if you look at the way that general MIDI works and the splits into the keyboard categories, piano, organ, synthesizers, stringed instruments of the plucked and bowed variety, and the various things that happen, it's quite easy to envisage a future where there are specialist working groups who are making woodwind controllers, who are making pianos, or let's say subtractive synthesizers, which all have very similar ways of similar conceptual models, so oscillators and LFOs and envelope controllers. You can support general MIDI and have to do all of this. Now you only need to do some of this if we split these off into different profiles. And different expert groups can move things in different ways, and it just means that we can move a lot more quickly as a group without being shackled to everything in general MIDI and all the whole gamut of stuff that general MIDI makes you need to support. So you can see a future where that happens and where percussion can be on any channel you like because you've configured a profile to be on a certain channel. Next thing is property exchange. This is very exciting because it completely changes the conceptual model of MIDI. So we always set property values by sending controllers or non-registered parameter numbers or any other kind of control change messages to another device. What we could never do is easily find a way of reading those controllers back from the device. The read-only stuff normally comes in a manufacturer-specific parameter dump, or some people put a button saying send all on their devices, which sends a massive great burst of control data from the device, but there is no way otherwise of reading back standard control messages. So we'll soon have a standard way of doing that, which should blow your mind in a very small way, because there are a lot of companies making controllers, and this has been a big limitation of controller technology for a long time. The next thing that should blow your mind even more is that we can do we will be able to do things, and remember the three disclaimers I made at the beginning. We expect to be able to do things such as finding the minimum and maximum expected values of a control, whether it's discrete or continuous, whether it's something you page through or it's better attached to a knob, and all those kind of useful things, and what the control mappings are of a device, so what you control with a particular CC number or NRPN, and all of that stuff can be read back in a status dump. And suddenly it makes things like novational native instruments, general control devices, and other general control devices are available. But it suddenly means that the experience can be much more automatic, much richer, and almost instantaneous. And the most mind-blowing thing is that we're exchanging property names, and we can start sending standard messages in well, nominally UTF-8 at the moment, but that's subject to final settlement, using JSON, which is this strange web development specification for exchanging hierarchical information. So we can do complete recalls and patch dumps of any device in a way that is readable by other devices. So you can do that wonderful thing of deciding that you don't like your 15-year-old Hammond organ simulator anymore and you want to buy the latest one, and your more complicated DAW now, because this stuff is it requires a little bit more of the transmitting device, will be able just to unplug the settings from that old device and transfer them to the new one. So they should sound the same. They should respond in the same way. The patches should be very similar. So all of this stuff is coming in capability inquiry, terms and conditions apply. But it is quite transformative in terms of what MIDI can do. Here is an example, and it's a very concocted example of the kind of stuff that's being worked on at the moment. So there's a universal system exclusive message that wraps up this JSON, and then somewhere in the middle there is this ASCII text, well, UTF-8, but they all look the same if you have the top bit clear, where you can transmit very standard bank program numbers, text. You can even stick tags in there that are readable, and all this stuff suddenly becomes a standard way of organizing patches and of storing status information in your digital audio workstation or between any two devices. Oh yes, there's an asterisk there, JSON payload. I need to point out the fact at the moment this might not necessarily end up being a JSON payload, and it might not look the way that it's just looked, and all of that stuff. So there's a separate working group called working on this part of this capability inquiry spec called Property Exchange. The two may not appear at exactly the same time, but the wrapper will be ready for the payload. I just wanted to make that clear because part of my job is to set expectations. And any engineer's job is to set expectations first and then meet them later. So I want to make sure that the expectations are nice and easy to surmount. In summary for capability inquiry, protocol negotiation for future proofing, so we can start with MIDI 1.0 and go faster or go richer when we want to. Profile configuration to assist compatibility of your device or any devices. And parameter exchange, which if you're making controller hardware is quite revolutionary and changes an awful lot. Initially, we're starting out with no protocols. There may be some appearing soon, but they're not part of the capability inquiry spec. And a few profiles for test purposes and just to make sure that the infrastructure works and is fit for purpose. But more can be defined. And if you want to define your own, if you want to design your own profiles, then I recommend you join the MIDI Manufacturers Association because it's very inexpensive and very good. Now I've got my plug-in now. And remember, all of this is draft, nothing is certain, so everything you've seen here may be a well-intentioned lie. Let's get on to the other exciting thing, next generation protocol. I can say very little about this because of the churning and the vested interest and the fact that if I start trying to nail something to the wall may move. So I'm going to say everything that I can about where we are at the moment and where we intend to get. You'll remember last year, maybe have 1,000 views, but I've only got 1% approval rating. I want to point that out. I'm not boasting. Last year I started introducing HD and where it was, and I want to make it clear that things have moved on quite a lot since then. HD itself has split into a kind of, and it's not called HD anymore, but it's kind of split into a long-term vision and what we need for the immediate future, which is a less disruptive, faster moving, easier to implement version of the MIDI specification that fixes the frustrations that people are facing on a day-to-day basis. And the long-term strategy is about what you might be using in some years' time. So that's how long-term strategy works. People want the whole chocolate shop, but actually if they're screaming, you just want to give them a chocolate bar for now. And the chocolate bar represents the things that people are finding very frustrating about MIDI now. And those are the things that we really need to deliver while not losing sight of the fact that it would be nice to build a massive chocolate factory. What you might look forward to, okay, it'll be negotiated using MIDI capability inquiry. We know that for certain, and it'll be on the protocol layer. It'll be a familiar approach. So while the note model for MIDI, where you have note on and note off, is constraining if you're building strange instruments where notes don't necessarily start at a point in time or they don't have a pitch associated with them, the conceptual model will be fairly similar to MIDI now, that notes will have numbers associated with them that may or may not pertain to pitch. But there will be starts of events and ends of events, and the whole semantic model can't change too much, because if it does, and you're trying to build an instrument that supports both protocols, you'll have to build the same instrument effectively twice in software, and we don't want to do that. Note attached parameters will be new, so possibly evolving MPE, which was a kind of note per channel version of MIDI to make MIDI expressive on a note level basis, which I made quite clear last year is a kind of sticking plaster for now, and it's as good as we're going to get using the current model. To actually have parameters that are attached to notes that can be defined at note start, change during the note, and finish at note end is one of the intentions of this protocol. More of what you like. So people ask for more channels. I think 16 channels is 15 too many, but other people need a lot of MIDI channels because they use MIDI in a different way. Controller numbers, so that we don't have the limitation of 127 controllers and then this big RPN and NRPN space. It looks like it needs tidying up, and it probably will be in some way. More bits of resolution, because people complain about 7-bit controllers being far too granular. And if you're making something like a mixing desk with a nice 200 millimeter fader, then it is far too granular. And 14-bit controllers are available, but not over the entire range of controls. Bandwidth, of course, so I've already talked about that. And less of what you don't like. And the thing that people don't like about MIDI is the non-atomic messages, where one piece of information is conveyed by several separate messages that are all kind of loosely, meaningfully coupled together, but not necessarily packaged in an official way. So NRP, setting a non-registered parameter number involves sending 4 separate control messages that a device has to aggregate and keep together and understand semantically in order not to mess things up when you're editing a MIDI stream. Program change messages are they're often preceded by a bank change message, so that's another piece of information where you have a control message and a program change message that meaningfully group together. And there are all kinds of examples of this in MIDI because of the way it's evolved from its very first implementations. And you have many different messages that semantically mean one thing and aren't the same message. So we'll tidy up that kind of stuff as well. So with any luck, all pieces of information will be atomic. That's what you can look forward to. So it's a tidy up of the MIDI spec rather than anything revolutionary, and more of what you like and less of what you don't. That's what we're for. And finally, I was asked to include this diagram because it's useful, but it's not really an introduction to capability inquiry, it's more of a summary slide. And if I started with this picture, I'd probably spent half an hour on the same slide. So this is how it all breaks down, and this is part of the specification. Capability inquiry in the middle, and you can talk to hardware and software devices bidirectionally, and arbitrate between them. In case of anything failing, if you're trying to negotiate faster protocols, it will always fall back to MIDI 1.0. So you're not losing anything by adopting this specification. And you've got protocol negotiation on the left, protocol negotiation on the left, profile configuration in the middle, and property exchange on the right. And this is my last slide because it's the whole of everything I've talked about in one handy rectangle. Thank you very much. Does anyone have any questions that I can forward to somebody else?
In fact, in terms of question, I think we should reserve them from the panel.
Okay.
We have a broader possibilities of responses.
That's basically what I'll be doing anyway. So.
Right. So if you'd like, you want us up there? Yeah.
Grab a stool.
Check 1, 2.
Act 2.
May or may not be live. Apparently I'm not live, which is fine.
You look alive to me.
Oh, well, there we are. Yes, excellent. Okay. Hello, everyone. Hi, I'm Amos Gaynes from Moog Music and the MIDI Manufacturers Association Technical Standards Board. And I have a cohort of colleagues here from the MMA. Tom White is MMA president. We have Phil Burke and Florian Bomers and JB, who are members respectively and collectively of the working groups who are working on everything that Ben was just talking about, and the executive board of the MMA. And between us, we probably know a thing or two about all of this and are interested both in answering questions and gathering requirements and ideas and inspiration from you based on what you've heard here. And also, not at all subtly, encouraging any of you who have ideas or your own agenda that you would like to inform this work as it develops to please join the MMA. That's the best way to, the best way to get your ideas heard and to become a part of the final standard is to join and contribute to the work. It is, we're a member-based organization whose purpose is to facilitate the work of our member companies. So if you are doing related work, please join us and pitch in and help craft the final standard. And so essentially, I think the best thing to do is to open the floor for questions based on Ben's talk, and we can riff on that and take it from there. So if anyone has any questions about what is coming in the world of MIDI and what you've just heard, please, by all means. We have one microphone for the entire room, I think. We may have to pass it back and forth or just speak up.
No, we should use the microphone because we have about 25 people watching online.
So very good.
So,
all right, maybe we can repeat the questions
we
as
should
we hear
repeat
them?
the question as well, but I can circulate the mic here. Well, should we start with question, or should we have everyone present why they're here?
The latter sounds fine. Sure, we can become less anonymous to those here and abroad.
Tom, would you start?
Yes, we'll pass it to Tom White.
I liked being anonymous. It was better, actually. Hi, I'm Tom White. I'm the president of the MIDI Manufacturers Association, and the only significant thing about that would be that I do not represent a member company. I am the one neutral person in the. I'm the mediator. How about it? I'm the mediator. The mediator.
Yeah. My name is Phil Burke. I'm with Google. And my background before Google, a lot of it was associated with experimental music and experimental intonation. So one of the things I was particularly interested in, and one of the reasons I got started with the new protocols, was because I was interested in opening up the pitch space and having fractional pitch and greater pitch control. So that was sort of my original agenda. Now working with mobile devices, they are particularly useful for sort of multi-finger gestures, where you can have instead of with a mouse you've got sort of one cursor moving, but with mobile devices with touchscreens you can have multiple gestures in action at once, with each with multiple dimensions, and want to make sure that that is can be expressed appropriately through MIDI.
So hi, so I'm Jean-Baptiste Thiebaud. I work at ROLI, and I got involved with the MMA when we wanted the C-board, which you may have seen before, which sends to reach an expression. We wanted to find a way for the C-board to communicate seamlessly with every software out there, and it just wasn't possible using one MIDI channel, and almost all software at the time were just listening to one channel. So we needed to find a way to encourage adoption, and we agreed with a few manufacturers, Roger Lynn and Keith Macmillan and a few others, to have the same exact way of sending data. Now we needed to convince the software world, and so we did manage to convince a few, or work with a few to get there, but to get it standardized, we brought that discussion to the MMA to have this idea evolve into a bigger and more established protocol. So now I've been working with MMA for 2 years, and what I'm very keen to see happening is to have more software engineers, software developers come to the MMA to represent that, because the hardware is very well represented there, but the software is a bit missing, and that's software rules the world now. So we need software plus hardware to work together. So yeah, Florian.
My name is Florian Baumers. I work at Baum Software, creating MIDI processing software and hardware. And well, my main interest in MIDI is to create expressive controllers, or to support expressive controllers to make more expressive music. And for that, I would like MIDI to be faster and have more resolution.
I'm still Ben Supper, and I am JB stablemate at ROLI, and before that I was at Novation for 6.5 years, so I've been involved in MIDI for quite some time. I chair the working group on MPE, so this polyphonic expression, which is now coming to the end, I think, of the development cycle in terms of getting the specification finalized. And I've been enjoying the tension between trying to get a specification right for as many parties as possible and trying to get it out quickly while it's still relevant and while there's still an urgent need for it. So the tension between engineering and marketing is a very interesting one, and it's something that that nobody ever finally resolves, and it's a very interesting place to be when you're chairing a working group.
All right, well, thank you everyone, and now I think I would like to request any questions or thoughts, opinions, desires, motivations, criticisms surrounding all of these concepts from you, the audience. Does anyone care to contribute? Oh,
all right,
fantastic.
Let's
please.
I'll review it in a second. Just
Oh, hi guys, it's sounding very great, good. I'm very excited to hear about it. Just a quick one, we're having more channels, for example. It does place a bit more burden on the receiving device to maintain the state. It takes up more RAM, for example. I think more channels is great. How about keys? Is there going to be more key numbers? because I'm kind of currently tied to 128, and it works really well, even for alternative controllers like guitars, things like that. So will there be more keys I'll need to support?
Well, that may depend on whom you ask and on which protocol you were talking about. I would say certainly there will always be MIDI 1.0, which will always have its same number of keys, and that's always the default or fallback.
Next generation, obviously.
Right.
So
Go ahead.
one answer is that there are manufacturers in their respective working groups who like more note numbers or key numbers to do more interesting things with it. But as you said, backwards compatibility is always a problem, memory constraints. So I don't think we can say something like that will come, but it's definitely considered.
Go ahead.
Just as in MIDI 1.0, there are some devices that, even though MIDI has 16 channels, there are some devices that only support one channel. And there's no reason that if a protocol supports hundreds of channels, a device needn't necessarily support all those. So we're looking at multiple different protocols, but generally there are ways to device to exchange information and be able to say, well, how many channels do you support? So that could be part of these capability inquiries. So a device might just say, I'm just going to be a really good, single channel device, and I'm going to support a 16-note range, and that's all I do. So even though the protocol may support many controllers and many channels and very high resolution, that doesn't mean that every device has to support all those. It could choose a small subset of capabilities.
Right. There would definitely be no hard requirement that one must support more notes than one desires, and there would be a language for negotiating, I support this many notes, okay, I'll only send you that many notes, etc.
That's almost the entire principle behind the capability inquiries, is to be able to say, we can actually issue a specification that has much more than anybody needs, and then they can pick what they need. You can just question it and say, do you support this? Great, thank you. That's all I'm going to do.
Yeah, that sounds great.
So we have one question here and then two.
Well, why do you don't you skip the old protocol and create a completely new protocol that is modern? I think about Ethernet connection. I think blowing up that old protocol maybe is something that could be happened 10 years ago. Now we are in a completely different time. Throw everything away, make a completely new protocol that is called maybe MIDI next generation, and have a fallback line, but separately coding. It's maybe a small side path, like the Intel has always this core processor that is make it compatible. But I think we want to maybe transfer even samples from these devices and make a stone that everyone can accept or not. The big manufacturers maybe say, okay, that's cool, transferring samples and between the workstations and so on. Maybe even a protocol that is capable DAW capabilities. And then you have a very good start with JSON, for example, new protocols that are very good to read, to handle, to parse, and all these things. I think this would be an approach that, for me, as a software engineer, would be the best one.
Funnily enough, almost exactly 10 years ago, we set out to do exactly that thing. And here we are 10 years later, and that effort did not succeed precisely because it was very hard to get industry buy-in for blowing up the old protocol. That was sort of the sticking point. And so where we have arrived now is the viable path forward, because there are, as Ben mentioned, there are billions of dollars at this point sort of invested in MIDI, and billions of devices which support it, et cetera, is rather than blowing up MIDI and saying, here's a completely discrete new protocol which is not backwards compatible, the idea is to negotiate a path forward so that MIDI is essentially the language in which you determine what this next how you get to the next generation is. You negotiate to it via MIDI. Once you establish that you can perform this negotiation, then the field is open for entirely new protocols which, once both devices agree upon them, can have all of these advanced capabilities and richness and transferring of huge amounts of information and at higher speeds. It was just that blowing up the old protocol was deemed non-viable by, enough of the industry was unwilling to do that it wasn't a viable path forward. But all of the work over that past 10 years in developing these feature capabilities, we should be able to deliver those via this less contentious method. That would be my initial response, if anyone cares to elaborate or fill in.
Anyone else want to add something, or we have a few more questions to go?
I would just like to reinforce the concept of how MMA works, which is consensus-based. So he was implying that, but I'm trying to be explicit about it. If you, for example, even in this room, that sounds like a great idea, but I go ahead and challenge you to get over half the room to agree with you, it's going to take some work. So that's the challenge inside MMA, too, is we had a bunch of people say, let's just do a completely new thing, and over half the people said no. So.
Okay, let's do that. Okay. So who wants to blow up MIDI and start something new? All right.
Yeah, that's fairly reflective of...
All right, so...
Exactly what we thought.
Yeah.
So for those watching online, there was like...
Doesn't mean it's a bad idea.
About 15%.
Hard to get consensus.
Yeah. All right, next question. Next question here, and then... Oh, you have a mic? Okay. So, Elliot, right there. All right, so we
hey there. So Ben, going back to your on the slide about the different profile configurations and having different working groups for, say, subtractive synthesizer makers or, organ makers. Has there been any thought about also doing that for on the hardware side? We've seen a big rise in and a trend in melodic grid controllers from GeoShred to the LiPad to Push. I'd love to see a working group based around sort of, defining, scales, keys, octaves for these. So, okay, I set a scale in my DAW, my plugin, and whatever controller I set, it will, lay that scale out for me. And, has there been any thought on that at all?
Well, that would be transformative. Specifically regarding that, there isn't a working group at the moment, but I would encourage people to set one up. And as we found with MPE, if you're working on a fairly open standard, that a specification for a way of doing things, it wasn't too hard to get 20 manufacturers interested in what we were doing and speaking in the same way, and to build that consensus up. So there's definitely room for that to happen, and I think if it did happen, it would very quickly become adopted because there's a real hunger for it. If hardware manufacturers can talk to third-party software and vice versa, then suddenly you go from having a few products that you're trying to sell to having a whole ecosystem you can cooperate with, and everybody benefits from that, both kind of commercially and technically. So that's my advert for making it happen. I totally think we should.
It would be absolutely brilliant if there were a common specification, a common language for mapping scales to these grid devices, which are also self-similar, except that there's no way to set that up automatically. Please join the MMA, help us make that happen. That is, I think that would be transformative, and you get a lot of buy-in from people who, as soon as they recognized that there were multiple people wanting to work towards that same goal, I think you could get a lot of buy-in on that.
How do you fancy chairing a working group?
JB, do you have the time? I don't know. Yeah, cheers, thanks.
Sure.
So we have another question over here. Aaron?
Yeah. Mine's quite simple. I really wanted mostly to thank you guys all. I know you're in the unenviable position of building consensus, and this is hard every year. I see these debates online and stuff, so thank you very much. Ben, I always love your presentations. I'm going to get on YouTube and give you a thumbs up so we can get you above 1%. But my questions are very simple. I got here late, so I wanted to know if there was a timeline for any of this, like a year from now maybe, is this going to be out? That kind of thing.
So back in 2005, we said we were going to do a new protocol. So does that answer your question? Unfortunately, we can't predict when we're going to be done because it's building consensus. So I can tell you that, and it's also, it's a policy not to try to mislead people. And then Ben did say that in the very beginning, that anything that we say could change. It's not our fault. Some new developer comes in and suddenly says, why are you doing that? You should be doing this. And we have to listen. We have to allow that conversation to go. So things could change at any time. Having said that, I think it's safe to say, and I have executive board and technical board members here who can correct me, that we do not think there's going to be another 10 years. We didn't waste that 10 years. We spent a lot of time talking about it. And we're here now showing this, although we're not promising anything, because this is coming. Something like this is coming. That's the best I can tell you. I just don't want to put a date on it, but it's not, I would say it's reality. Something's going to happen.
Right. There are working implementations of some of these things for multiple manufacturers talking to each other presently, and there's a lot of momentum and will to finalize these things in the indefinite but near term. Real soon, maybe.
Stefano, yeah.
Yeah, thanks for all the exciting news. Really waiting for it. All the points that Ben, you mentioned were mostly related to point-to-point communication. Are there any news when there's like a network of devices? For example, today mostly you divide devices. You say, okay, one device is that channel, another device the other channel. Is there going to be something like that? This device can negotiate which feature to implement in a network of multiple devices?
Who wants to take this? It's a very good question.
To take a stab. So we have a fraction of engineers in the MMA who would love to do that, but as you can imagine, it complicates the whole matter a lot. So it's at this point, it's not really considered as a feature, but I think we should make sure that it cannot be excluded for the future. So to not delay the standardization process even more, but it's definitely very useful, and so I think it should come eventually. I would want to have it. I'm creating network MIDI hardware, so that would be very cool to have it.
Yeah, my recollection is that the original HD protocol working group devoted some time and thought to articulating those problems and trying to define a sort of a solution space. That work is not currently embodied in the items that Ben was talking about. Being wildly hypothetical, perhaps there could be something like a network controller profile that defines the capabilities that such an entity needs to have, and then a language for implementing those capabilities. But that represents future work at this time. But I think the path to enable that work is under construction.
This is another case where I'll ask the technical standards board people to correct me, but related to that question is oftentimes those kind of things you're talking about are done through a host computer. And it is possible that the people who control that environment may solve that on their own. Is that ambiguous and vague enough? I'm just saying that Florian's answer was that we had, inside the MMA, we had discussed those kind of things and thought that maybe we should solve that, and maybe that is not where the solution should be. Maybe, I'm not arguing one or the other, the host computer can solve that, but I don't know.
Yeah. I mean, those sort of network protocols can be implemented without support from the operating system, as long as the operating system provides networking, network stack. People can build protocols like they build OSC for communicating between applications or between devices on a network, and the operating system doesn't have to know about it. Whereas if we have a protocol that is using USB, the operating system has to support that protocol. So these networking protocols are actually something that could be done without the coordination of the operating system and the device manufacturers. People could write things that run on Raspberry Pis and an application that runs on a Mac and another application runs on Windows, some on Android, and they could all talk to each other tomorrow if they agreed on a protocol.
Right. Adam.
Hi. Phil mentioned his interest in intonation, and I also have an interest in intonation and tuning, and I just wondered where things are at with in the near future with things like maybe a note having its own frequency information.
Who wants to take this?
I think it's fair to say that, well, we can't say anything specific about what commands or packets or what's in or what's out, but I think that support for arbitrary intonation is seen as something that supports markets that are beyond the 12-tone equal-tempered, cultural standards of, Western music, and I think that there's that idea is shared throughout. That's one of the least controversial issues. Pretty much everyone goes, "Oh yeah, we want to have fractional pitch." So I think you can be fairly comfortable that there will be some kind of support, but I can't be specific about what that would look like.
Right. The well-defined approaches are under discussion for very fine pitch resolution and properties that are associated with notes or with voices. And so, every approach under consideration treats those as important considerations that should be implemented.
So I think we have time for one more question. Over there.
You were mentioning there at the MMA that you were desiring more software engineers to participate, and I was wondering if you would host a GitHub or something where you could have resources for libraries in various popular languages and platforms where people could adopt these protocols. You can read the protocol sheets, but I've been around for a while and not everybody parses MIDI perhaps appropriately, and you run into kind of interoperational issues. So if you had some example code or some common libraries that people would want to contribute to, say, in an open source or GitHub, that would be very useful. So I was kind of wondering if you'd comment on that.
That's a very good question. I'll leave you to answer in a second, but I just want to point that, Juice obviously is open source, and it has an MP implementation, for example, that's there. And any new significant changes in MIDI will do our best to continue to provide open source examples. So you don't have to use our implementation, but at least you can see how it can work in practice.
We have a GitHub repository we're using internally that's open for MMA members. So when we talk about how would we parse this kind of a packet, we might, people will post codes like, this is how I would do it. And it's like, oh, that looks easy, or that looks hard. So we're already exchanging code right now because software engineers tend to think in code sometimes a little more easily than they think in terms of text documents. But we can't make those repositories public until the protocol's public. But once the protocols are public, I'm pretty sure that there will be public repositories where we can exchange, parsing libraries and things like that.
Tom, might that be something that the MIDI Association wing of the MMA might care to facilitate?
Yeah, so that's another response, or part of the response is that traditionally, first of all, the MIDI Manufacturers Association is a horrible name because manufacturers implies hardware. But so I want to make it clear, although it says manufacturers, we mean companies that make MIDI products, whether it's hardware or software. But even at that, what we've realized after 30 years of doing this is that part of the success of MIDI is not just the manufacturers who build the products, but also the users who use them. Because everybody who uses MIDI products knows they're using MIDI. It's not like USB where everybody has USB, but you have no idea what it's doing. You actually edit note-ons and note-offs, and you move controllers, and you know that's what you're doing. So the success of MIDI is not just the manufacturers, it's also the researchers and the educators and the composers, and everybody, retailers even understand it. And yet there's no forum, there's no association for them. So, and in fact, our organization, MIDI Manufacturers Association, was never really concerned about them. Our focus was making sure that manufacturers built interoperable products. Having done that, that's great, except that we need some way to get out to all those other people who are using it and explain the things we're doing, like we're doing here, meeting, talking with you. So in order to enable even better communication and fostering education and everything else, we now started a second organization called the MIDI Association. So we removed manufacturers. It's a separate organization from the MIDI Manufacturers Association. You still have to qualify to become a member of the MIDI Manufacturers Association, but the MIDI Association is free and open to anyone. We took all the specifications that we used to sell, all the MIDI specs, and put them up there, and all you have to do is you go to the website, midi.org, and you register, and now you have access to all the websites. There's forums, there's tutorials, there's blogs if you want to write an article about something that you're doing, if you want to communicate with people. So that could become a developer resource as well, where you would not have to be a MIDI manufacturer's member. You could just be a developer. And of course, we'd still want to encourage developers to join, to participate in the standard setting activities, because we need the feedback and the input. But we certainly could do, we could pretty much do anything on the MIDI Association part of our business operations that anybody wants, including setting up GitHub stuff and distributing resources.
Okay, we're out of time. Thank you all very much for attending. Developers, please join the MMA. Everyone, please join the MIDI Association at midi.org. Thank you very much.
Thank you.
And thank you to my distinguished panel of experts.